So today I'm going to talk about Python 3. Believe it or not, when I made this talk, I actually was very surprised that no one was already giving a talk like this because it sounds very basic, right? Python 3 is the next generation, and it's already been out since December of 2008, so I thought that somebody would have created this talk already, but that was not the case, so it's my job to fill in the empty holes. Okay? So, about me, actually there's too much stuff to read here. Easiest thing is, I teach, I write, most importantly, I code. So, that's probably the most important thing. That's all you need to know about me, nothing else. Alright, how about you? So I assume you have some Python knowledge and experience. I will not cover the basics of the language here. Which is probably the reason why you're at the conference. You already know Python. So today I'm going to focus on talking about Python 3, the differences between Python 2 and 3, what does that mean for 2.x, and what is the timeline and recommendations and guidelines on the transition. Okay, so a lot of people have asked me over time a lot of different questions over the last 4 or 5 years. And so this presentation attempts to answer some of those questions. So some of those questions that people ask me are, what does this mean? What does Python 3 mean to Python 2, and why is it so important? And what's the big deal? I think the thing that makes people worried the most, a working battery. The thing that has people worried the most is that it is not backwards compatible. So everybody's scared of that. So my job is to make it so that people don't have to worry. Because that sounds like a very scary thing, especially when you're writing software. If it's backwards incompatible, that means it's not usable by anybody. So so that's a big concern that people have, and I just want to make sure that for me to do my job, I want to make sure that people aren't worried. It's not that big of a deal, and you really shouldn't have to freak out that the next version of Python is going to break all your software. I mean, it is, but in a nice way. Okay, so. Other questions are, do I have to rewrite all my code? How much time do I have? Is it coming soon, or is it here, or whatever? What about Python 2? Is it like really bad for me to learn Python 2 now because it's completely obsolete? And is Python being completely rewritten? Will I even recognize it? Which one should I learn? Python 2 or 3 if I'm new? What is the migration plan? All that kind of stuff. So those are basic questions. Of course, are all Python 2 books obsolete? So that's kind of a funny question, maybe only targeted for me. But what are the differences between 2 and 3 anyway? So I hope that in the next, 60 or 80 minutes, let me just check my time here, that I have time to answer all of these questions. Okay. All right. So the rumor is true. There actually is a Python 3. Okay. Some people are surprised. I know it's already there. So the language is at the crossroads of a big change, and it's changing to the next generation. So in the past, I've been using Python for almost 15 years now. My focus, whether I'm teaching a class or writing a book, is to promote version independence of releases. I'm all about teaching people how to program Python and how to do it well. And I'm not really that concerned about, what are the differences between 2.4 and 2.5, between, 2.6 and 2.7. Because usually when you're just, getting up to speed on the language, it's not that big of a deal. So I really don't pay much attention to the differences between releases. But the one problem is when we move to Python 2 and 3 is that it is backwards incompatible. So there has to be some thought given to that. And so I can't ignore that. So, why does Python 3 even exist? One of the reasons is, as Leo was designing the language in the early days, he made decisions that were correct at the time. And, unfortunately, some of the things that ended up being flaws in the language have been hanging around the language for a long time, all of these years. So, does everybody know that Python is 20 years old? as of a few months ago. Some people are completely shocked by that because it doesn't, it's like, oh, I only wrote Python like 3 or 4 years ago. But no, actually, he released it on the internet in February of 1991, so it has been around for quite a long time. So 3.x means is a chance for the core Python developers to fix these early design flaws, to make more the data types consolidated, and to get rid of any old features and models in the language that aren't used anymore, and to add a lot of improvements to the language to make it more usable. Okay. Basically, it's about the evolution of the language. If you don't evolve, you're going to die. So that's the main reasoning. So what is the plan? The plan is that Python 2.x will live on for some time. It actually has not been completely end of life yet. In fact, 2.6 and 3.0 were developed in parallel. So usually the case is, oh, just forget about 2.x. Let's just move on to the next one and just drop the old one, right? But because the core developers are concerned about the community, they decided to keep them both being developed at the same time. And on top of that, to bring a lot of the 3.x features back into 2.x so that it helps you prepare to migrate your code to Python 3. So, and they've also developed a bunch of migration tools. For example, I will talk a little bit about the 2 to 3 tool, as well as Python 2.6 and newer. So those things are all important as well. Okay, so if you want to find out more information, look into PEP 3000 and 3100. Okay. In fact, Python 3 used to be called Python 3000 a long time ago. We don't call it that. That was the marketing name. And he promised that it would be on time or early. Okay. All right. So let's answer some of those questions. Is all my Python code going to break? Probably yes. Okay. Do I have to rewrite everything? Hopefully not. Hopefully porting won't be really bad. I think the only real struggle you'll have is moving between ASCII strings and Unicode strings. That's probably the most painful part. The easy stuff is easier. Unfortunately, the hard stuff like strings is harder because a lot of your applications are going to be using strings. And of course, people think about it negatively. When you just say the term backwards incompatible is usually not a positive thing, right? You don't think of it in a happy way, right? So that's the real thing. And then of course bloggers don't know what that means, and they think, oh, gloom and doom, the sky is falling and all that kind of stuff, so you have to ignore that. But it is true that a 3.x interpreter will not run most 1.x and 2.x code. But the good news is the language isn't changing so drastically that you will not recognize it anymore. The syntax is pretty much about the same, but it's very easy to break the language when print changes from a statement to a function, because all of a sudden you just broke like 90 to 95% of all Python code out there, right? Can't do anything without print, and most people will not put parentheses around things, right? One of the things I had to get used to when I learned Python 14 years ago was you don't have to have parentheses around your if condition. Okay, and that took a little while to get used to, as well as the semicolon at the end. So you can tell Guido's, appropriately Dutch, very minimalist, not a lot of extra symbols, no semicolons, no braces, no parentheses, and just not a lot of dollar signs or anything like that. So kind of like this comes from Guido, all right? And believe it or not, backwards compatibility has never been a problem with Python because the team is so, feels that backwards compatibility is so important that they go out of their way to make sure that, 2.6 doesn't break 2.5 code necessarily, all right? In fact, when Python 2.0 came out in 2000, it was really no problem at all running 1.5.2 code or 1.4 or whatever version people were using back then. In fact, a funny story is, well, actually it's not funny at all. It's funny me telling you. Python 2.0 alpha came out on the same day as Python 1.6. Why? That's another story for another time, perhaps over a beer or something. I'll tell you about this long story. But basically, nobody used 1.6, and there was a reason for that. And Python 2, moving forward, Python 2 was developed at the same time as 3.0. Why? I'll tell you about that coming up in the next few slides. So the cost, of course, of backwards compatibility is that you have these flaws. And when you have these flaws, you keep them around for release after release after release. And then there's these features that have been in the language for a long time that nobody ever uses. It just causes extra code load, right? You don't need to have that extra code. It makes it slower, makes your code harder to understand, maintain, read. There's code coverage is very important, and if you don't have people using it, then it's kind of a waste of time. So that's the cost you have to pay. And in fact, two really well-known people in the Python community, so Guido is one on the right, and Andrew Kuchling is on the left. I think this is the only known picture of the two of them together. But this was, I think, 1997, around 1997 timeframe, where they were both in the Washington, D.C. area. And both of them came up with papers or essays that describe what they feel are the problems that Python has. What were the things that, for Guido, his essay was Python regrets. What were the things that I thought were real mistakes that I made? But I didn't know that at the time. At the time, it seemed like they were the right things to do. And Andrew wrote the Python Awards paper, so you can Google for those and just see what they think were the problems with Python. So these things kind of like formulated the sort of like the creation of how Python 3000 started to begin with. So why is Python changing? Well, the first thing you should recognize is that Python isn't changing. Okay, I mean, it usually doesn't. It's always been backwards compatible. Python 3 is still recognizable by you. You can look if you know Python 2, and then someone gives you Python 3 source code. You can pretty much still figure out what's going on. It's not being rewritten or redesigned from scratch. It's just they're removing a lot of old stuff and changing certain things that need to be changed. Of course, it's not a standard. But unfortunately, it is backwards compatible for the future. Like I said, you have to evolve or you're going to die. So all of these old flaws and stuff have to go away. So it is the very first release that deliberately breaks backwards compatibility. Of course, they don't really want to do that anymore because it's very painful. So no one's promising that it's not going to happen again in the future, but it did take 18 years for the first one to occur, so hopefully not for at least another 18 years. Again, I already mentioned that backwards compatibility is always very important to the core team, and it's always a high priority. So, it's just following the agile method of development, right? It has to be iterated over too, okay? 3.0 is just a slightly bigger jump than previous releases. All right, so here are the main differences. Print and exec in Python 2 are statements. They will be converted into functions in Python 3, so just be aware of that. Strings, the default strings in Python 2 are ASCII, and then there's a separate Unicode string type. In Python 3, they're completely switched around. So Unicode strings will be the default. ASCII strings are going to change names, and it's going to be called the bytes type. They're also going to add a new byte array type as well. True division. So 1 divided by 2 is actually going to be a half. So I know many of you are very passionate that 1 divided by 2 is 0. Okay, I know that. But Python is used a lot to teach children how to program. And you can't really convince a 10-year-old child that 1 divided by 2 is 0. Okay, they're just going to get mad at you. All right? So that's one of the reasons for that. I know. And if you have to have flow division, that's fine. You just use the 2/. So I'll tell you about that in a coming slide if you didn't know about it already. There's a change in the syntax for exceptions. There's a lot more iterators everywhere. Some class updates. So believe it or not, between 2.2 and the last 2.x release, which is probably 2.7, there are actually 2 class types in the language. All right, some people don't know that. It's like a double language. Okay, it's living 2 lives. One of them is live, and the other one is moving on. Sounds like a line from a movie, doesn't it? You cannot compare mixed types, so it used to be the case that you could do that. You could sort things. You could call list.sort on a list that has numbers and strings now. That's kind of undefined, right? I mean, that is undefined. It doesn't make any sense, but Python 2 still does it, and it just guesses. Okay, like it thinks you want all the numbers first, and then all the strings after that. Okay, but in Python 3 that won't be allowed anymore, so you actually get an error. Let's see, what else? Just some other minor changes. So I'll go into many of these in more detail. Okay, so let's start with print. This is the easiest way to slip up in Python 3. If you just want to start experimenting with it, this is your first syntax area. Okay, almost guaranteed. You just don't do the parentheses because it's out of habit. So why is it changing? Well, if it's a statement, you can't really add things to it. You can't fix things, you can't add new features to it. So that's probably the main reason. Now that it's a function, you can always add new keyword arguments, and if nobody knows what those are, your code still continues to work, right? But you can add new features. You can also wipe it out, right? Because it's a built-in function, it's no longer a keyword. So you can actually replace print by something that you create, right? Because maybe that's the right thing to do for your application. And if you want to find out more about the change to the print statement, take a look at PEP 3105. So in my slides, I actually use this terminology. Anytime you see BIF, that just means a built-in function, and then FF stands for factory function. So just kind of like keep that in mind in case you see those abbreviations. All right, so here's just an example of using print the current way of doing it in Python 2. Fairly straightforward. I deliberately left the comma out here so you can see that it does string concatenation automatically. And by putting the comma, you get a space. Okay, so I did that on purpose. One of the nice magical things about 2.6, 2.7, and all the remaining releases starting from 2.6 is that they're actually backporting a lot of these features to the language. So you can actually start writing Python 3 code right away. So if you really want to write Python 3 code in 2.6 or 2.7, you can actually bring in the print function and get rid of the print statement. All right. Once you do this import of under a feature dot print function, you will no longer be able to use print as a statement. Okay. So you can tell when I press print here, this is print a blank line. It actually tells me that's the function, and so now I can actually use it. Okay. So that's a good thing. And of course, in Python 3, it is mandatory. You don't have a choice but to put the parentheses. And of course, again, I also left the comma over here too. All right, shouldn't be too big of a deal. All right, strings, Unicode by default. Of course, for those of us who spent many years writing Python code that deals with European characters, Latin characters, and also Asian characters, it's been very difficult. Pretty much every Python programmer has run into this, right? Everybody raise your hand that you've run into that before. Look at this. Turn around and look. Like 90% of the room has raised their hand, right? It's unbelievable. Okay, it's just something so basic. Like I can't believe, like cafe just breaks my code, right? So it's horrendous. So this change is really welcome for those of us who have been dealing with this issue for a long time. In fact, it got so annoying, and people kept on running into this problem so much that I ended up writing a nice blog post about it because I need to explain it to myself every now and then why this is the case. So I can probably find it on my blog still. I wrote it a couple of years ago. But this is basically because you have non-ASCII characters in correct 8-bit strings. It just doesn't know how to convert to ASCII because there's no equivalent ASCII character. So if you want to find out more about Unicode, there's a link down there you can go to. Also, I'll upload the slides to the page for the talk so that you guys won't have to write things down. Okay, so the main point, of course, is not just Unicode versus ASCII. It's really the difference between text versus data. Because text is something that's supposed to be human readable. Data is just, a variety of anything that you have stored, but you're storing bytes, right? So that's a big thing, all right? So text is represented by Unicode. These are what real strings are supposed to be, human readable, things like that. Data refers to anything that you want to deal with, ASCII characters or raw bytes or 8-bit strings or any type of binary data, right? You shouldn't be penalized if your application involves all these different things, right? Even though these last things don't have anything to do with ASCII strings, right? So the string type is being changed to the bytes type. There's a new B literal now, so you can actually do B and then quote, and then your string and then quote. The Unicode string type changes names to str, so it takes over as str. There's no more U, leading U. Also, in Python 2, base string used to be the base class of both the string and Unicode. But they've gotten rid of that, so there's no more base class for strings. They're all independent now. They've also added a bytes array type. So strings and Unicode strings are immutable by default, right? You cannot change them. So bytes array is actually the same as bytes, except that it is now a mutable type. So if you want to deal with actual bytes as an array, and you want to change those, then that's what a bytes array type is. And there's like 4 PEPs that you can take a look at to help you get more information on the new string level. again, I mentioned a few minutes ago that since Python 2.2 to 2.7, there are actually 2 class types, and the reason for this is in Python 3, we're going to get rid of the old ones. Okay, so the problem, let me see if I can talk about the problem. Yeah, okay, problem's coming up, so I'll tell you about the problem and the reason why we do this. So 2.2 is actually the first step to unify classes and types, because, believe it or not, they used to not have a relationship to each other. And this is very shocking to people that are new to Python. What do you mean classes and types aren't related to each other? Classes are types, so it just seems so strange that you can't speak about them together. So that was one of the early flaws in Python. It just like blew my mind. Like, what? I can't subclass a type. What are you talking about? That's crazy. That's not object-oriented programming. That's like I don't even know how to describe it. This doesn't make any sense to me. So those old style classes are called classic classes. So when you read the documentation, you see that reference. You know what that means. And the next generation of classes is called new style classes. And Python 3 gets rid of classic classes so they no longer exist. All classes are the same type. You only have one class type moving forward instead of 2. So 2 very big pets are 252 and 253 that you can take a look at to give you more information here. All right, so classic classes. What were the problems with classic classes? Well, normal classes in regular object-oriented programming language have it so that classes are types. Makes sense. And instances are objects of those types, right? And that makes sense to everybody. Whether you've done Java, C++, or any other object-oriented programming, that's what is the right thing to do. But the problem was that Python's classic classes were not normal. Classes were class objects, instances were instance objects, and there was really no relationship except that your instances had a pointer to your class object. But notice I didn't say the word type anywhere there, okay? So that was a real problem, and because of that, you could not subclass existing Python types. You actually had to make fake ones, okay? So if you guys ever see any code that imports user list or user dict, those are classes that fake as lists and dictionaries that you can't subclass and modify, okay? So it got to be that bad that we had to make fake classes that emulated Python types, and then we had to put them in the standard library, okay? So that was horrible, just horrible, so I can't wait for those things to go away. So here's what the difference between the two of them syntactically. So whenever you see a class that does not have a base class after it, or it doesn't inherit off of a base class, that is a classic class. So if you guys are writing classes like that, don't do it. Okay? Put at least a parent object after it. So object becomes like a new root class, root base class of all class objects. And that's how you make a new style class. Now, if you have a subclass, if you deal with a subclass and you're not sure whether or not it is a classic class or a new style class, you actually have to go up the class hierarchy all the way to the top to see whether or not the very base class of your subclass or the very ancestor class of that subclass either has nothing or has object after it. If it has object, everything that's inherited, all derived classes will be new style classes. Same goes for if you define a classic class, every derived subclass will be a classic class, right? So that's what it is. And in Python 3, so that it doesn't break existing code, both of them will only create new style classes regardless of whether you have object in it or not. Okay? Okay, so that's classes. Now let's talk about exceptions. So in Python 2 and of course Python 1, there are different ways of raising exceptions and different ways of handling exceptions. So in Python 3, we've consolidated those types so it's less confusing. There's only one right way of doing things and not like a whole bunch. Okay, so you can read more about the change in exceptions in text 3109 and 3110. So if you're catching or handling one exception, the syntax looks like this. You have except followed by the name of your exception, comma, the instance, if you want to state the variable as to like why did this exception happen. Okay? In order to capture handle multiple exceptions using the same handler, okay, in other words, the same block of code, you have to put more than one inside a tuple or a tuple, all right? They have to be inside parentheses, okay? So again, E or whatever, variable name you decide to use at the end is the exception instance that it usually has the reason why the exception occurred. Now, the mistake that most beginners make is they try this and they get an error, okay? Because it just doesn't work, right? You'll just get a syntax error. And the worst thing is if they get that error and they put the whole thing inside parentheses, that's wrong too. Okay, so it just doesn't work at all. All right. So to help get rid of this confusion, as has become a keyword starting in 2.6. If you use it in 2.4 and earlier, you won't get any kind of indication that that will become a keyword. In 2.5, you will actually get a warning that, hey, the next version of Python, as and with is the other one. They will become keywords, so change your variable names. All right. So the same things apply for this new syntax, except followed by the exception name. We're using as now. And then on the second one, same thing. You still have to have multiple ones in parentheses, but there's no comma at the end here. It's as. Okay? So it's easier to distinguish between exceptions and the reason for the exception. So this is required starting in Python 3.0. Any Python 2 that's 2.6 and newer will accept either the comma or the as. So you can start coding against Python 3 that way as well. So it's great that 2.6 and 2.7 do both the comma and the as, just because that's very helpful in reporting. And you can read more about that in tab 3110. All right, let's talk about raising or throwing exceptions. I'm not sure how to say this because, in Python, one of the Zen things is that there's usually one right way of doing things, right? Unfortunately, there are actually 12 ways of throwing exceptions in Python. And I've listed all 12 in my book just because I couldn't believe it. I thought it was just going to be one or two, and I kept on going, and it turned out I had to stick it in the table. It was so big, so that's pretty bad. So the most popular ways of raising or throwing exceptions over the years are these two ways. One is where you're just raising the exception. The other one is where you're raising the exception, and you want to pass in the reason why the exception occurred. All right. Again, there should be only one right way of doing things, so this seems very odd that Python has 12 ways of doing it. Why did that happen? Well, they didn't do it on purpose, all right? Guido did not say, you know what, I'm going to let my users throw exceptions in 12 different ways, okay? Not quite very well there, but the main reason for it is that exceptions used to be strings a long, long time ago, before you even touched Python. Exceptions used to be strings, and because strings have no relationship to each other, there was no hierarchy involved. So the smart thing was to change the classes. So that change happened at 1.5. It was very interesting because I learned Python at 1.4 and I'm like, it's kind of a big change between versions. So it kind of made me nervous a little bit. But anyway, they were changing classes in 1.5, and you guys know how to instantiate a class, right? You call the class as if it was a function, right? There's no new keyword, you just say class, parentheses, and then whatever arguments go to under and init. So these also became allowed value there, whatever exception for in paren, exception followed by the reason. Okay, so this is so that made these happen. And in Python 3.0 and newer, you have to raise exceptions this way. You can no longer do it the old way on the previous slide. All right. So it's kind of funny that since this change, it's sort of like, this is a transition tool starting Python 1.5 even before anybody thought of Python 3, so it's kind of funny in that way. And of course, when they were changed the classes in 1.5, those were classic classes. And in Python 2.5, they were actually changed to new style classes. But you still instantiate them in the same way. The only difference I showed you earlier was in how you define the class. Okay. So I've actually given this talk a couple of times at previous Python and PyCon conferences. But EuroPython is special, so I added some new slides that those other people didn't get. So anytime you see the asterisks, that means this is a new material. All right. Actually, in reality, they only gave me 60 minutes, and so I needed new material for 90 minutes for this session, so I added those for that reason. But I'm just making you guys think you're special. You're not. Oh, yes, you are. But you're here, listening to me. Okay, that makes you very special. All right, so updates the integer. Believe it or not, there used to be two integer types in Python. There's an int type, and then there's a long type. Okay, so you can tell what a long is because it has a big capital L at the very end of the number. Okay, so for example, if you're using like MySQLDB, importing stuff from MySQL, you're getting a row count back. It has like 2L. which is kind of overkill. You don't, 2 can fit in a regular int. It doesn't have to be in a long, but, so anyway, so 2 integer types have been unified. There's no longer a long type. Division operator is changing, as I mentioned, and then some minor changes, and I'll talk about all those right now. All right, so in the past, there were 2 integer types. Integers used to have the size limitation, so, if you're on a 32-bit system, ints were unsigned 32-bit ints on a machine. They could also be 64-bit, but you have to, be on a 64-bit architecture, running with a 64-bit compiler, okay, and of course a 64-bit operating system. So all those things have to happen in order for you to get ints to be 64 bits. And if you exceeded the size of your int, like, you did, 2 to the power of 100, and you tried to assign that to an int, you actually got an overflow error. And Python also had long types, and those actually were unlimited in size except for how much virtual memory you have. And that's where the trailing L comes from, okay, to kind of differentiate them between regular ints and long ints. But, after a while, people began to realize, why is this the case? Why even have ones that have a size limitation? Because a lot of scientists and mathematicians use Python. If you're dealing with large prime numbers, you don't want to run into this. It's annoying to scientists, okay? It's a waste of time. So the decision was made to unify both types so that now there's a single int type and there is no size limitation. Now, of course, it still sort of exists under the covers in Python source code, but there is still 2 types. But as far as people who use Python and develop code with it, you don't have to worry about it anymore. So starting in Python 2.2 and every release after 2.2, small steps have been taken to unify ints and longs together into a single type. And because there's minor changes in every release, I actually put that in my book as well, just one little section at a time to show you what are the differences between 2.2 and 2.3, 2.3 to 2.4, 2.4 to 2.5. But I think most of those changes are pretty much done now. And you can actually also see that in the PET too. They kind of like outline, we don't want to make this change all of a sudden. We just want to make it gradual and slow, and so that it finally happens. And of course, it's all done in Python 3. There is no more long type, so you cannot use numbers with an L anymore in Python 3, and you'll get an error. You get a syntax error if you do that. Okay, no more overflows. If you have a regular int and you go over the size 32 bits, it will automatically convert to a long enough that covers it. You don't have to worry about it. So I mentioned that the division operator is changing. Again, the main reason for this change is that it doesn't give the expected answer for new programmers. And so it's been changed, so it does give the expected results. So there's terminology here. We're talking about classic division, floor division, and true division. And there was controversy with this change. You can imagine many long-time programmers that are used to 1 divided by 2 equals 0 weren't very happy about that. So you can probably look at all those flame wars. But people are still passionate about it. I know some of you guys are really quiet, but you really are one of those 1 divided by 2 equals 0 people. Okay, so I know that. But I won't ask you to raise your hand or anything. Okay? So classic division is the default 2.x division symbol operation. If the operands are int, you're going to get floor division. In other words, the fraction is truncated. If you have at least one float, both numbers will be converted to float, so that you'll always have true division here. Okay, so you're always going to get a float, even if one of the operands is an integer. As long as the other one is a float, you're going to get a float. Okay. So again, the other integer is coerced to becoming a float before the operation can happen. So there's an example. The second example down here, 1.0 divided by 2 gives you a half because at least one of those is a float. So true division is the default division symbol operation for 3.x. So this will always perform a float division. You always get a float back. And again, it's very difficult to explain to a child why 1 divided by 2 is 0 instead of a half. And if you're doing physics, and you're trying to figure out, rate times time equals the distance, if you divide by one of them, it actually doesn't work out well either, right? So that messes up physicians too. So regardless of what your operands are in Python 3, you're always going to get floor division or true division. Now, if you really want floor division in Python 2, there's a new division operator, which is a double slash, and that was actually added as a migration tool to Python 3 in 2.2, so back in the early days, about 8 or 9 years ago. So this will always give floor division regardless of the operand types, and you can see that whether you're using ints or floats or whatever, you're always going to get floor division. Okay, if you want to access true division starting in Python 2.2 and newer, or So that's 2 all the way to 2.7. You just import under and future dot division. Again, true division is default starting at 3.0. You can also change the behavior of your Python interpreter with the startup -q option. So if you start Python 2 with -q old, you're always going to get classic division. If you start, actually that might work in Python 3 as well. I'm going to try it again. If you start with -q new, you're always going to get true division. If you do -q warn, it's going to warn you whenever it comes across integer over integer division. And if you do warn all, that will warn on all division operations. And for more information on this, we've got 258. All right, so enough about division. Let's talk about integer literals for a little bit. So this was inspired by the existing hexadecimal format. So you know that a hex number is 0x and then a hex value, all right? So the changes are coming to octals and binaries. So octals are changing, binaries are new, and these things I'm going to tell you in the next few slides are required starting in Python 3.0, but they are available starting in 2.6 as a transition tool. You can read more about these changes in Python 30.07. Sorry, 31.27. All right, so the binary literals are brand new. Okay, so this is a brand new integer literal format. It has not existed in any previous version. And unfortunately, this is one of the exercises that I've had in my book for the last 10 years. You know, convert an int and display it in binary format. So they messed up my exercise. Not good. Every time there's a new release of Python, one of my exercises becomes not an exercise anymore, which makes me mad. So I have to do more work every time I have to write a new edition of the book. So anyway, besides that, there's a new built-in function called bin, and then of course change, octal, and hex built-in functions as well. So I'll talk about that. So octal has been around for a long time, and the way you do octal number is you have a leading 0 in front of it. This is confusing to some users, especially programmers. So, you know, because hex has a 0x, we should make it so that octal is 0o. Okay, so there's a new little o. Okay, so you can see that in Python 1 and 2, the octal number 177 has a 0 in front of it, and in Python 2.6 and 2.7, as well as all 3.x, you have the 0o there. Okay, and of course the octal and hex built-in functions have to be changed in order to kind of adopt these new values. Of course, because as the transition tool was backported to 2.6 and 2.7, of course, you can use all the formats. So you can use it with 1, 0, or you can use it with 0, O. The new binary literal got added in 2.6 as well, to backwards compat. If you use the old octal function, you will get the single leading 0, but if you import the new octal function from future built-ins.oct, okay, so oct is future built-ins.oct, then you'll get the new one, and the new one has the O. So I don't know if this is important to you or not. I don't really deal with octals very much in my daily work, but if you do, then you can use that. All right, so that's enough about numbers. Let's talk about iterators. So another theme of Python 3 is memory conservation. There are iterators everywhere. So iterators are much more efficient than having to create entire data structures in memory. So it used to be the case that, oh, you know, you'll just like make a list comprehension to hold this data because it's really cool to use a list comprehension, right? The problem is you can run out of space very quickly, okay? Because making a list can take a lot of memory. And if all you're doing is building a list just to iterate over it, then you've created that list for no reason, okay? It takes a lot of memory. So a lot of things are changing using iterators now. Things that used to return lists will now return iterators instead of lists. Okay? This includes dictionary methods and some replacements to existing built-in functions. So let's talk about those. Dictionary methods. So dict.keys, items, and values return lists in Python 1 and 2. So this is where you get all, you know, if you call .keys, you get a list of all the keys. .values give you all the values, and then .items give you all the key-like pairs. There are also iterator versions of these called .iterKeys, .iterValues, .iterItems. And these things, instead of returning lists, they return iterators instead. So what's going to happen is these guys are going to replace and be renamed as the original keys, values, and items. and you will no longer have the iter names at all in Python 3. So if you do dict.keys in Python 3, it's really calling dict.iter keys in Python 2. Okay? The main reason for that is not to inconvenience you. If you really have to have a list, then just pass in the list and you get a list of the keys. If you want a sorted list of keys, and you can just call sorted on it. Okay, so you can always call a list on something that you want to have as a list. Okay, give you more about dictionary methods in PEP 3106. You have a question?
A sorted list? Don't I need to do sorted list D?
No, because D is an iterator now. So that's the other thing that's changed in Python 2.2 is that dictionaries have become their iterators. So as you iterate over a disk like for K in D, you actually get the keys out, right? So this is the same thing. So you don't have to even use .keys anymore, actually. .keys is very rare for people to use now. But before Python 2.2, that was the only way to get a list of all the keys out. But now dictionaries, starting in 2.2, have become their own iterator.
Because sorted does not return as an iterator, does not return a list. That was the question.
Oh, the question is sorted. Does sorted return a list? I think sorted still does return a list.
Sorted returned a generator once, I think.
I think reversed returns an iterator. One of them returns a list, the other one returns an iterator. I don't know why that's the case. I have to go and find out to figure out the historical reasoning behind that. Anyway, if you want things sorted, it's sorted, but maybe it comes as a list instead of as a generator. To me, it would be nicer if it was just an iterator. All right, some other changes. So similar changes are happening to built-ins besides dictionary methods. So all of these four functions here that return lists in Python 2 will return iterators in Python 3. So map will return an iterator filter, and so will zip. Xrange is a special case. I'll talk about that. Other built-ins they've added some new built-in functions. They've changed some of them. They've moved some of them around, and they removed taken out some of them. In addition to the changes above. So for example, the reduce built-in function gets moved into functools module. Raw input becomes input. More information on these changes to the built-ins are in PEP 3.1.1. So map and filter. So map and filter currently in Python 2, they both return lists. So there is an itertools module that has an iterator called imap and then another one called ifilter, and both of these become the new map and filter in Python 3. Actually, map and filter themselves have sort of already been obsoleted kind of by list comprehensions and generator expressions because you don't really need to use them anymore because of that syntax. So wherever you need a list, you can use a list comprehension, but to be better with memory, you should use a generator expression instead. So a long time ago, when list comprehensions came out, they were so neat. I used to tell everybody, oh, you should use list comprehensions because they're really cool. And then, now that I've become more conservative in my ways, I tell people not to use them anymore. Instead, I tell them to use generator expressions instead because the syntax is pretty much identical. The only difference is you change your square bracket into parentheses, and you have the same operation, but you don't have to build an entire list in memory. Again, it's a waste of time. All you're going to do is iterate over it anyway. You might as well just make it an iterator and save memory. Okay? Now, if you need it for speed, I can understand. Okay, because if it is all in memory, then it goes faster. So still pick the right tool for the job. All right, so other changes. So xrange is basically the same as the iterator version of range. So how we have dict.keys and dict.iter keys as the iterator equivalent. Well, xrange is the equivalent to range, but it returns an iterator. So in Python 3, xrange replaces and is renamed to range. So there is no more xrange in Python 3. Zip is replaced by itertools.izip. And there's also one for files. So files.readlines used to readlines, as you may know, returns all the strings in your file in a list. And an xreadlines does the same thing, but as an iterator. So file.xreadlines becomes file.readlines. Actually, file objects are gone too because they all become IO objects instead. So There just won't be any X reruns. Okay, so other changes, we already talked about integers being changed. I just also mentioned that IO classes are going to replace the file object. You can read more about that in F3116. Dictionaries, I also mentioned, in addition to the method changes we just talked about earlier about keys and bigger keys, there's also going to be dictionary comprehensions. Okay, sets also get set literals, which I don't have here. I should actually put that in these slides. So new set literals, and I'll show you, at least I have a demo of that coming up on a future slide, but I should have mentioned it here though. So set literals, new set literals, and then also new set comprehensions. And also tuples or tuples, they've never had methods ever because, you know, they're immutable objects, and if you do want to execute something on them, you should use a list. But there are two methods that are read-only anyway, and so it's sort of a waste of time to have to take the contents of a tuple, convert it to a list, execute these methods, just to use them to get these numbers out. So I'll talk about that as well. Okay. All right, so let's talk about dictionary comprehension. So this was inspired by a combination of dictionaries and list comprehensions. A lot of people pass in two tuples to create a dictionary with. All right, so what this will do, so what dict does is that it takes the first and second tuple elements and makes them the keys and the value. So if you pass in some big list of, you know, key, comma, value as a tuple, key, comma, value as a tuple, it'll actually make a dictionary where we have key, value, key, value, key, value. So that's a very common pattern that people use to create dictionaries with. Now you don't have to do that anymore. You can actually use dictionary comprehensions. So the syntax is curly brace, key, colon, value, or whatever you want to have here. I have a more complicated example down here for key and value in these two tuples. Brace uses curly brace because that's the delimiter for dictionaries. So here's one you can actually change your key and the value. So for every key and my value, so I'm going to zip range of 5 and 0, range of 0, comma 5, and then range of negative 4, comma 1. So that's really 0, comma minus 4, 1, comma minus 3, etc. Okay, so what I'm going to do in this case is I'm going to take the key as is, but I'm going to modify the value and make it multiply by 2 so that my resulting dictionary that's created is 0, colon, minus 8, 7 minus 4, 1, colon, minus 6. So you can actually do logic inside this while you're going to use this in the same way that you define a list comprehension, but do it for creating a dictionary instead. So that's pretty cool. I think people will be using these a lot because they seem pretty fun to me. There's also sets, so here's the set literals. Now you can actually use this. Instead of doing set and then putting a list or a tuple inside with all your set elements, you can actually do curly brace now. Values in your set, comma, 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 all right? So it shows you that there's a close relationship between dictionaries and sets. Of course, curly brace by itself still means an empty dictionary. You can't make an empty set that way, so you still have to use the set factory function to create an empty set. You can also do set comprehensions. So it follows the same, syntax as list comprehensions, generate expressions, and dictionary comprehensions. So here in this particular case, I have 10 to the power of I for I in range of 5, and you can see I have now a new set, and you can see that it uses a set literal now. And you can tell it's not a dictionary because there's no key, right? You don't see a colon anywhere. Whenever you have something in curly braces that there's no colons, you know that's a set. Okay, of course, as a reminder, if in case you were wondering why these numbers are not in order, it's because dictionary and sets are hash types, so ordering is never guaranteed. Okay? Sometimes they'll look like they're ordered to fool you, but you should never rely on them to be sorted. Okay? So nice stuff. Now, back to tuples again. So again, for the first time, tuples will have methods, specifically count and index, because count will count how many times an item appears in a list. Index tells you where's the first one, what is the index value the first time that object appears in your list. Now, if you have tuples and you're dealing with them a lot, it's a waste of time, like I said earlier, to have to convert that to a list just to call these methods, just to index, or to get this number that you can use for your tuple, right? It's pointless. Tuples are immutable, that's fine, but these things don't affect the contents of the tuple, right? I'm getting a number that tells me something, and that's all I care about. So this is unfortunately a common pattern for people that deal with tuples a lot. They have to use these methods to find out what's in them, have to convert to a list. So we're just making it so that we add these methods to tuples so you don't have to worry about that anymore. All right, and this of course makes sense because these are, again, read-only operations. on a type that you're not going to change the data in any way, right? So there's no point. So then there's other changes, small changes like changes to reserved words and built-in function to change, some operator changes, types, and also the package are changing as well. So we'll go into each of those too. We have about 15 minutes left. So reserved words. So these include statements, constants, and keywords. Okay. So these are now reserved words in Python 3. You cannot assign them to variables. So as with non-local, true, and false. A whiteboard here, but some of you might not know that true, false are not constants or reserved words in Python 2. So if you have somebody at work that you really don't like, you can do false comma true equals true comma false. See what happens to their code. Okay? Now the reason why these were not constants, which blows a lot of people's minds, like why aren't these should be constants, right? Well, the reason is because Boolean types is only added in Python 2.2. Before Python 2.2, you would just see this pattern in everybody's code. False equals 0, true equals 1 at the top of everybody's program. Okay? And if you all of a sudden in Python 2.2 when Booleans came around, if they were keywords, guess what? All that code will break. And so the team really believes in backwards compatibility, so that's why they were not keywords to begin with. So now is a chance to just break away from that. Python 3, let's make them keywords and just move on. Print and exec, because they're changing the functions, they're no longer reserved words, so they're taken out. Bunch of changes to built-ins. There's new built-in functions, ASCII, bin, exec, memory, view, mix, and print. Reduce has been moved to functionals, I mentioned that already. And these other ones have been removed, so apply, callable. Actually, callable is one of those really interesting things where callable was removed for 3.0 and 3.1, but so many people wanted it that they added it back in 3.2. So I should put a star there. Callable is back. It's gone for 2 releases, but I mean, who uses Python 3.1 and 3.2? I mean, 3.0 and 3.1 anyway, right? In fact, Python 3.0 had so many flaws in it that only lasted for 6 months. So it wasn't very long at all. So compare, course, exact file, internal, but these are all removed, or they probably got moved and not replaced. Yeah, so map and filter got replaced. I should have put raw input on that list because raw input changed its name to input, and the same goes for actually that's xrange too. So map, filter, hex, input, op, range, and zip are different from Python 2. They still exist, but they're different. Built-in methods, I already talked about the changed dictionary methods. There's also some new string and tuple methods, file methods, because files got replaced by IO classes and their methods. So I don't think anybody was using the less than, greater than for not equals, but that was actually valid in Python 1 and 2. That came from ABC and Pascal and Modular, if you're familiar with those languages. So we're just going to go with 1 now, so it's just bang equals. Also, the single backticks, that used to be the notation for REPR or repr. That got confusing as well. So some of you guys came to my talk yesterday. I kind of described how bad this was in one particular case because I actually used backticks in the first edition of my book. And in the second edition, some editors thought that I really meant apostrophe, so they actually changed it and broke the code. Okay, and of course readers are mad at me because I did it wrong, but it wasn't my fault. So, it's like, let's just avoid using single backticks, so just use REPR from now on. Types and factory functions, so bytes type and the byte array type is new. Okay, so they're both new, so that's why they've just been added. Also range, it's, put this in italics because it's not necessarily added, it's just that it's what xrange did. And xrange actually is its own object, even though it's an iterator. Xrange objects existed before iterators did, because xrange has been around since Python 1. So that's why it's sort of like a type. So if you actually call xrange in something in Python 2, you actually get an object out of it. It won't say it's an iterator or anything like that. Okay. So remove, there's no more base string, base class for strings, as I mentioned. Buffer is gone, long is gone, Unicode is gone, and file and xrange, of course, are gone as well. All right, a lot of changes. I'm not going to go over all these, but these are changes in modules, in new models that were added, models that have been taken away, modules end up being replaced, so you can go through that on your own time, but the list is just too long to go over in a talk. But just to show you that they're really getting rid of the really, really old stuff. And certain things are unified together into packages like URL lib, URL lib2, URL parse, and robot parser. All four of those have been merged into one big URL lib package. And then same goes for the HTTP package. All of these have been merged into that. And then similarly for XML RPC, all of these things have been merged into one package. Same goes for DBM as well. All right, so let's talk about migrating to Python 3. So are there migration plans or some sort of transition tools available? The answer is yes. So what should you do? Definitely develop a plan. You can't just go and sit down at your desk one day and say, I think I'm just going to hack it out. Okay, it's not going to work. You have to have a plan. But the most important thing, I think, is to wait for all your dependencies to port. Because if you're relying on something like a database adapter or Django or something else that don't exist in Python 3, well, you're not going to port, right? What you can do is, as an exercise, you can sort of start porting your code, but don't expect anything to run yet because you don't have any of the underlying infrastructure that you're relying on. Okay? Make sure you have a really comprehensive test suite for your Python 2 code, because one of the first steps they recommend is that once you port to Python 3, you want to keep on running these test suites to make sure they still work. All right? If you don't have good testing in your Python 2 app, that means you're not going to have good testing in your Python 3 app. Okay, that's really the bottom line. So follow these migration steps as I go through them, and there are migration tools which I'll talk about as well. All right, so the plan is, and you can read this in fine detail in the What's New in Python 3 document, but again, you should wait for your dependencies to port first, unless you want to do it as an exercise. There's nothing wrong with just doing it to practice. Okay. Again, make sure you have really, really good test body. Because you are going to rely on those to prove that your code is still correct in Python 3. At least start moving your company or whatever your hobby is to the latest Python 2. And it should be at least 2.6. 2.6 is the very first release that has Python 3 features backported to it. All right? And of course, if you do Python 2.7, even better, because there's Python 3.1 and 3.2 features that have been backported to 2.7. Use the -3 command line switch. So what happens is if you run Python with -3, it'll actually tell you against the things in your code that are incompatible in Python 3. So that's pretty useful. There's also a 2 to 3 tool that you can run on the command line. And what that will do is that will take an existing Python 2 source code and output the diffs that you need to turn into Python 3 code. And if you do -w, I think I probably have this on a future slide. If you do -w, it'll just create a new, it'll rename your Python 2 one and replace that with the Python 3 version. So you can actually just run that on an entire, directory of Python files. Make sure all of your, make all the final tweaks that the 2 to 3 tool doesn't do, and make sure all your tests pass. How much time do you have? You have a lot of time, okay? That's my opinion. When is Python 2 going to be end of life? The quote is a couple of years, whatever that means. Python 2 will be around for as long as it takes for people to migrate all of Python 3. Guido wants Python 2.7 to be the very last 2.x release. If he has to, he'll do 2.8. He really doesn't want to do 2.9. And of course, definitely no for double-digit things. So there's going to be no 2.10. Because that's too ugly. So, but he's going to try and make 2.7 the last one. We're on 2.7.2, so there will be 2.7.3, 2.7.4, 2.7.5. So I don't know how long it's going to take before we end up having a 2.8. Okay. All right. So here are the exact steps mentioned in more detail. All right. Again, port to the latest Python 2.x. That's going to be not as hard as, it's going to be the same as you porting from 2.4 to 2.5, right? If you're on 2.5 now, port to 2.6, right? Make sure all your tests pass. Use the -3, run your tests again. Fix your code until there's no more warnings and all your tests will pass. Run 2 to 3, okay? And make sure that all your tests pass again. So here's what the -3 switch does when you run it. It'll tell you about, you have dictionary.haskey, which is actually being removed. You could just use in, right? If k in dictionary, you don't need haskey anymore. But before Python 2.2, before we had the in operator, we had to use haskey to ask whether or not a dictionary had a key. Same goes for apply, and I guess port callable is going to be removed from the -3 switch. Python 3.2, at least I hope it is. Coerce, exec file, reduce, and reload, all the things that are not built-in functions anymore. So the 3.2 tool, well, here's some more information about it. What does it do versus what it does not do? Okay, so it'll change your backtick, single backticks to RPR. It'll convert your print statements to functions. It removes the long suffix, changes all your less than, greater than to not equals, and it changes all your callable calls to has adder. I don't know if the 1 in 3.2 does that anymore, or it leaves it as callable, but hopefully it leaves it as callable. So it does little minor syntactical differences, changes to show you. And there's a long suite of different things. So if you have something new you want to add to it, it's just like another file that you add to the 2.2 to 3 library. But it's not a crystal ball. It can't predict certain things. Like it cannot stop using modules that are no longer there. Because these modules can change all the time, right? It might not be obsolete until 3.3 or something like that. It can't start using new modules that don't exist yet. It can't start using new features like class decorators. And it can't you can't automatically convert your code from using lists to iterators and generators. You can read more about the 2 to 3 tool with that link there. There's actually a 3 to 2 tool, which is not in the standard library. This is a separate one, but this sort of like goes backwards. So what that does is actually takes Python 3 code and backports it to Python 2 if it's possible. So this was kind of interesting. I didn't know about this last year. And when I found out about it, that was a very interesting project to work on. Very aggressive. But it does exist, you can look for it. So Python 2 is not end of life yet, it's quite the opposite. 2.6 is the first one that was backported with 3.x, so 2.6, 2.7, and I don't know if there's any future one. It's a very important role because they actually have so many of these 3.x features that you can actually start writing Python 3 code pretty easily using these languages or using these versions of the interpreter. And 2.x again and 3.x are being developed in parallel. There's separate teams working on 2.x as well as 3.x. I already mentioned that 2.6 and 3.0 were almost released at the same time. Both teams are moving very well in parallel, and they were both going to come out at the same time, because Python 1.6 and 2.0 came out at the same time, so they kind of want to make that happen as an inside joke for those of us who've been in the community for a while. But 3.0 still had some issues, so it actually took an extra 4 months before that came out. So 2.6 came out around August of 2008, and 3.0 came out in December. So the point is to keep 2.x alive for as long as it takes to migrate users. I personally, again, my opinion, 100%, I'm going to call for a decade, which means I don't think the world will be completely in Python 3 until 10 years after Python 3 was released. So 2018 is when I think everybody will be on Python 3, but that's just me, because I know how much time it takes to move, especially large companies that take longer to move. Okay. So what are some of those features of 3.x that are available in 2.6 and 2.7? New style classes, true division, changes to exception handling and exception raising, unified integers, new integer literal changes, bytes type, class decorators, access to some built-in functions, built-in methods in Python 3, and access to some of the new models and packages that have been backported. Not all 3.x features are able to be backwards portable to Python 2. So, for example, print has to stay a statement. You can explicitly switch to the built-in function, but once you change to the print function, you cannot access print as a statement anymore. So you have to be careful there. And then some built-in functions with 3.x behavior can be imported. Okay, so all of these guys are in future built-in, so you can import those. Python 3 status. So this is just talking about the different distributions of Linux. So C is current, F is future, E is experimental. And you can take a look at that website there to show you what is the current status of Python 3 releases in all of these different Linux distributions. Yeah, so anyway, it's not that important, especially if you're not a Linux user. But if you are, you can see which ones fully support 3.0, 3.1, 3.2, etc. So as far as how many things have been ported, so the Python package index, or PyPy with a PI, or a PP, or a PIPI, or the cheese shop is the easiest way to say it. Okay. So when I gave this talk at PyCon in March, there were 350 packages that were Python 3. In just 3 months till now, already 100 more have been added. So this number is growing very quickly every day. So you can see the migration of the big jumps and time frame that it takes. And there's a link that you can actually get to pull up only the Python 3 packages that are in the Cheese Shop. But if you want to see like a pictorial graph of the growth of Python 3 packages, you can go to Jorg's link here, and you can get the latest one. You can see that the growth has really taken off very recently at the beginning of this year, as opposed to back in 2008, 2009, there wasn't a lot, and in 2010 here. You can see the growth is, so there's definitely people pouring to Python 3, but it's probably not going to be large-scale adoption until most of the big packages like Django or Twisted and all that stuff has been moved. All right, so here are some of the big names that have been ported to Python 3. So VirtualM, SQL Alchemy, Mako, NumPy, SciPy, set of tools, the Oracle model, Python, DocUtils, Jinja, LXML Markdown, the Postgres module, Swig, Win32. So there's already a lot, CherryPy, I forgot to mention. So there's already a lot of packages that have been moved over, and more are being added every day, but it does take time. So again, as long as your dependencies have been moved over, you can feel free to port. So if you want to track the Python ports, just there's 3 different websites that are keeping track of these things. You can take a look at them. There's probably more, but at the time I did this talk, there were 3. And there's a whole bunch of recommendations on how to do porting. Some of them are newer, some of them are older. So again, you can just download the PDF of the talk and get these, so you don't have to write these down. And so the feature coming up, Python 3.2.1 was supposed to be released yesterday, so maybe today or maybe tomorrow. I don't know if anybody in the room knows, but it's imminent. So 3.2.1. 2.7 is on 2.7.2 now. So 2.7.x, 2.7 should be the final 2.x release. Like I said, we don't want to go anymore. 2.7.2 actually came out last week. So Alex Gaynor was proposing that he thinks it's possible to port Django to Python 3 this year. So we'll see about that. He wants that to be a Google Summer of Code project, so I don't know if they've got people lined up for that yet. And then Python 3.3, if you want to find out more about that, the release schedule is PEP 398, and that's estimated for August of 2012. So it'll be a while. So 3.2 will be the version for a while. So they'll probably be delayed beyond August. All right. So how about books? Do I have existing? So which one should I use? So if I have existing Python 2 code, which version should I learn? I should learn Python 2. Okay. If you don't have any baggage, any software that exists, you can start learning Python 3. There's nothing wrong with that. Okay. There are some Python 3 books, but they're probably obsolete because they're written against 3.0. Okay. So you have to be careful. They're not all that useful yet. Are all Python 2 books obsolete? Not yet, because Python 2 is not obsolete yet. All right. It's much easier to learn because there's a lot more Python 2 books and tutorials online. All right. There are hybrid books coming soon. So I promise that the 3rd edition of Core Python, which is what I'm working on for the next few years, will have Python 2 and 3 combined, because I think the transition will take so long that it is a bad idea to stay in Python 2, but it's also a bad idea to completely port to Python 3. So in the 3rd edition of my book, I'll have Python 2 code and Python 3 code next to each other, or maybe not next to each other, but on top of each other or something like that. Okay. So to wrap up, Python 3 exists because the language is evolving. Believe it or not, the language is here. I mean, 3.x was out in December of 2008. Okay, it's been around for a while now, but so is 2.x. It's still around as well. It is backwards and compatible, but not in such mind-blowing ways that you won't be able to recognize it. It's to improve and evolve the language and get rid of some of these sticky flaws. Still a little rough. You're still going to feel kind of uncomfortable with the ASCII versus Unicode thing. You're going to get errors, and you're not going to make too much sense. You're still going to have to work around those. But the transition, again, 2.6, 2.7, we've got a lot of backward features. You've got the -3 switch. You've got a bunch of these migration tools that I talk about. In the end, once everything is said and done and Python 3 is stable, then you'll enjoy Python more. But you probably still need to wait a little bit before you port. Okay. There were a lot of Python 3 talks given at PyCon this year, so if you want to look them up, all of them are recorded, so you can find the videos online. So these are just some of the ones that I recommend. I'd like to see you guys at some future conference. So I'm here at EuroPython, but I'll also be going to also be going to some of these later on in the year. And I'm also teaching a class in San Francisco, so if you want hardcore Python and you want to learn more about it, and you want an excuse to come to San Francisco, then come talk to me because I have some flyers or whatever I can give you. Okay? And that's it. Thanks for coming to the talk. Hope you enjoyed it. So are there any questions? Oh, by the way, I don't use Python 3 yet, I forgot to say. Because I work at a very large company, and I don't really use Python 3 yet, so it'll take a while. We're actually just starting to convert to 2.6. Large companies take a long time to migrate, okay? So it's just be aware of that. So anyway, if anybody have questions? Oh, sorry. Usually I walk around more because I have a lapel, but since I don't want those attached,
You passed it.
I don't walk around as much.
Just one quick question. Do you have your presentation somewhere online? Because especially the PIP number, so...
Yes, the presentation, I will upload it within 2 hours. It will be on the EuroPython website.
Okay.
Okay.
Just pass the microphone.
Yeah, next question.
Other questions?
Really? Only one?
What about the performance?
What about the performance of Python 3? Yeah, that's a very good question. Python 3.0 benchmarks slower than Python 2.6, much slower. Python 3.1 benchmark as better, but still not, I don't think it's faster than 2.6. 3.2 is an improvement on that. So as they're making fixes, they're making improvements to performance. So I think they're about the same now, but maybe a little slower still. So yeah, but the first one was just unusable. That's why it didn't last long enough. They had to order certain things to see for 3.1 to actually make it perform decently. So, but since I don't work on the Python 3 development team, I can't give you a more specific answer. But there is a mailing list for the core devs of Python 3 that you probably can find something online. I'm sure someone's measuring that. It's very important. Any other questions?
Yes.
Or you can just talk to me in the hallways too, because I'm at EuroPython for most of the week. So, all right, thank you everybody.